Okay, so we've all seen what AI can do these days. Things like ChatGPT can write, they can code, they can even make art. It's incredible. But all that success in the digital world, it actually raises a really fascinating question when we start to think about the physical world.
I mean, really think about that. If an AI can whip up a complex essay in seconds, why is it so ridiculously hard to get a robot to just fold a t-shirt? It seems so simple, right? But that question, it gets right to the heart of a massive technological challenge. Why is one so easy and the other still feels like science fiction?
Well, the secret sauce for generative AI is its training data. It had, you could say, an incredible shortcut. It got to learn from basically the entire internet. Billions and billions of pages of text, code, and images. All of humanity's written knowledge already digitized, just sitting there, ready to be absorbed. So what about robots? What's their library?
And that, right there, brings us to the core of it all. It's really a tale of two completely different kinds of data. For one AI, it's like having a library card to every book ever written. For the other, well, it's like having to learn to read and write every single word from scratch, one painful letter at a time. Let's just break this down side by side. You can see it clearly here. Generative AI learns in the digital world from text and images. Robots have to learn in the physical world from actual interaction. And look at that last row, data availability. For digital AI, it's abundant. It's already there. For robotics, the data is scarce and incredibly expensive and slow to create. That's the whole game, right there.
And this sentence just says it all, doesn't it? Language, code, pictures. They're already in a format a computer can understand, but the physical world, with all its textures and weight and physics, it doesn't come pre-packaged in ones and zeros. You can't just download the feeling of a coffee mug's weight.
So okay, what does it actually take for a robot to learn from the physical world? Let me tell you, it is so much more than just seeing an object and knowing what it's called.
Think about what we do without even thinking. A robot has to learn all of it from the ground up. An intuitive grasp of 3D space, how to keep its balance, how much force to use to pick up a delicate egg versus, a heavy brick, the split-second timing needed to catch something, and just the basic laws of cause and effect. If I push this, it will fall. None of that comes from reading a web page. And this quote, this just hits the nail on the head. Every time we pick up a cup, our brain is processing this fire hose of sensory data, the temperature, the texture, the weight, how our balance shifts ever so slightly. That's the rich, juicy, physical data a robot needs, and it is brutally difficult to capture digitally.
And here's the real kicker, the practical bottleneck. To get this physical data, a robot has to physically do something over and over and over. Every single attempt takes time. It costs energy. If the robot breaks, that's real money. And how do you even standardize the data for a messy room when every single messy room is different? It's a logistical nightmare. And that leads to another huge problem. See, it's one thing to have a robot on a car assembly line, doing the exact same motion a million times. That's a solved problem. It's a whole other universe to build a robot that can clean your kitchen, where a chair is in a different spot, the sunlight is hitting the floor differently, or someone left a banana peel on the counter. It has to adapt, not just run a pre-written program.
Now, you might be thinking, hold on, what about self-driving cars? Aren't they robots navigating the real world? And yeah, that's a fantastic question. They absolutely are. But they also happen to be the exception that proves the rule because they operate in a very specific and relatively structured environment. Just look at this. A road, for all its complexities, is a pretty structured world. It's got clear lanes, traffic signs, rules everyone is supposed to follow. It has a logic to it. Now compare that to your house. It is pure, beautiful chaos. Cluttered floors, changing light, unexpected obstacles. It's a completely unstructured environment.
Okay, so the problem is huge. We get it. How in the world are researchers trying to bridge this massive gap? How do we actually teach a robot to learn in our messy world? Well, one of the most promising strategies is this clever three-step loop. First, you let the AI practice millions, even billions of times in a simulated virtual world. The key here is that failure is totally free, and it's super fast. Then you take all that virtual learning and transfer it into a real robot. And finally, that robot goes out and refines its skills with actual real-world experience. It's a continuous cycle.
But, and this is a really important but, we gotta be realistic. This is a practical strategy, but it is not a finished solution. A simulation can never, ever perfectly replicate the sheer messiness and physics of reality. Still, this cycle of virtual training and real-world practice is probably our best shot right now at cracking that physical data bottleneck.
And this whole challenge is pushing us to think about a completely different kind of intelligence. It's not just about processing language. It's about something we could call physical intelligence. It's the ability to act and adapt based on experience, on context, and on this deep, intuitive understanding of how the physical world actually works.
So here's the big takeaway, the one thing to remember from all of this. The fact that we don't have robot butlers folding our laundry yet isn't a sign that robotics research is failing. No way. It's a sign that they are tackling a problem that is orders of magnitude harder than the one generative AI has already solved.
And that just leaves us with this one last kind of mind-bending thought. As we keep chipping away at this incredible problem of physical intelligence, will the journey of teaching robots how to understand our world actually force us to completely transform how we understand intelligence itself? It's something to think about.